This black hole is really big. It has at least 20 billion times the mass of our Sun. And one of the mysteries is how could it grow to such a big mass in such a short time? Because we see it actually way back in time. The light from this black hole has traveled to us for over 12 billion years. And that means we really see it in a stage in the early universe when the universe was just over a billion years old. So it's a lot of mass to have put on in the short time frame of a billion years, even for a black hole. It's still growing. It's growing at this fastest rate, and that's why we could see it. Growing very fast makes black holes very bright, incidentally. And it's ironic that we haven't seen it for a long time, that we haven't found it before, because, I mean, you can't see it with a backyard telescope. It's not that bright. You need professional kit, but you don't need to have a very big telescope to pick it out. It shines among a billion stars out there. It's just sitting there. What is hard is actually to recognize it for what it really is. And that's what's holding us up. But what this discovery shows us is there are these monsters out there that we've overlooked for a very, very long time. It just shows us what's possible in the business of black holes. Now, we don't have a wonderfully precise understanding of black holes. Black holes really are pretty bizarre things, even by the standards of astrophysicists, and we'd like to understand them better. They influence the galaxies in which they live. We have a black hole at the center of our own Milky Way galaxy, but it's a fairly small one. It has only 5 million times the Sun of the mass, so that's 4,000 times smaller than the new one we have found. They influence the galaxies they live in, and also we just don't understand from the physics point of view how you can grow them so quickly. So we would like to find the most extreme ones that are the hardest ones to explain, just to push the envelope and see how big a problem do we have to solve. We believe there is something like a speed limit for how quickly you can grow the black holes, and this one is within the speed limit. It's just fine. But if you calculate backwards what sort of small black hole it must have started out as in order to grow to what it is now, it wasn't a very small black hole at the beginning when it first formed. It must have had something like 5,000 times the mass of the Sun. And we don't know how to form such black holes. We know how to form black holes that are 50 times the mass of the Sun. You get this just from the collapse of a very massive star. We see this happening. This has happened in the early universe. So we can start from a seed black hole of 50 solar masses and then grow them over time. But we don't know how to make a much more massive one to start growing from. So we might learn something about how you form black holes or how you grow them.